Yes,
So
sir.
you know what tension is. And if I'll get to the mood and ask you what exactly it is, you will say it is force on one part of the system by the other part, right?
Yes,
Yes,
sir.
sir.
So now when we have taken a spring, I ask you the same. When now we are dealing with spring, not string, please distinguish. Now we are dealing with spring, not string. So now as I'm dealing with spring, I'm asking you the same question, which is the spring force internal force, to which you did admit, yes, it is. Your admission is spring force is an internal force. And then I ask you, okay, let me take a spring and deform it by x. You'll ask me, what do you mean by deform it by x? Are you compressing it by x or you're extending it by x? I'll say, for your convenience, just to let you know, let us extend it by x. Though deformation in itself is a complete sentence. You need not specify you have compressed it or elongated it, because I need not ask you what mode you are in. What will I ask you only is by what quantity you have deformed. Is it okay?
Yes, sir.
Yes,
Yes,
sir.
By what quantity you have deformed. So deformation will entail compression as well as extension. Am I clear?
Yes,
sir.
sir.
So you need not go that specific what you are into doing. But as you have asked me, and this is to begin with, let me tell you that I'm extending it. And extending means I'm elongating the spring, and elongating by what quantum? By x. So if I elongate a spring by x, then what will come to me certainly is there will exist internal force everywhere and it will exist in pairs. Agree?
Yes, sir.
Yes,
There
sir.
will exist internal force everywhere and it will exist in pair. Are you endorsing my statement?
Yes, sir. Yes, sir.
Why are you going to watch from where stems your endorse? It stems from the fact that internal forces are always present in pair, right? Yeah.
Yes, sir.
Yes,
Yes, sir.
sir.
So spring force being an internal force, what we are to say that it relates to a spring, and we are dealing with if at all we are dealing with linear spring, then magnitude of, and I repeat, magnitude of spring force will be directly proportional to first power of displacement. Magnitude of spring force will be directly proportional to first power of displacement. Am I clear? What
Yes,
does linear relate to? Am I clear? What
Yes, sir.
does the preface or epithet linear relate to? What did
yes,
I ask you to read it against? Is only and only linear spring. When I say linear spring, I am taking into consideration only what IT is to lay credence to. Therefore, we restrict our study to what IT will lay credence to. And IT is not to go beyond the ambit of linear spring. Am I clear?
Yes, sir. Yes, sir.
yes, sir.
We will ask you only on linear spring. So we are containing ourselves to linear spring. Nevertheless, we are not oblivion to there can be springs other than linear. Then comes to our understanding what exactly this word is to be read. Let us try to decode it. And if we are into decoding it, then we decipher that linear means first power of deformation. Linear means first power of deformation. Is it okay? In any case, whichever case you will study for you, linear will translate to first power of deformation. That deformation can be in the form of extension or in the form of compression. That means what I am to say, FSP. If FSP is what I am using for magnitude of spring force, is it okay?
Yes, sir.
If
Yes, sir.
FSP is what I am using for magnitude of spring force, then I am to say FSP is directly proportional to X. Then what I have to say, FSP is directly proportional to X. And then what we are to qualify our study with is we are limiting it to linear spring. Correct, yeah? That is a qualification. And that is a bracket that we are to keep to. Correct, yeah?
Yes, sir.
What bracket we are keeping to? We are relating to linear spring. And by linear, what I mean mathematically, x is raised to the power
1.
One. Single
x
power
is
of X.
raised to the power 1. Correct, yeah?
Yes,
Yes.
sir.
Okay. So what we get when we remove sign of proportionality is a constant of proportionality. What we get when we remove sign of proportionality is a constant of proportionality, and this constant of proportionality is what I was referring to as spring constant or stiffness of spring. Clear?
Yes, sir.
Yes,
Constant of proportionality is what is referred to spring constant or stiffness of spring. Now, I am going with what you find in books, and
Yes.
I need to understand why whatever is written in books, any book you pick, why what is written in books or in package is to inflict confusion. I'll come to it, but first let me go ahead with what books write. And this is what they do write. FSP is equal to Kx. Let us now take an example in which a spring of natural length. When I say natural length, I mean a spring is not deformed. Is it okay?
Yes, sir.
Yes,
The
sir.
spring of natural length is being taken. What is length of the spring taken? Is L naught. Spring of natural length is being taken and is to mass m nailed one end of it. Find here. So one end is nailed to the mass m as shown in the figure. The other is nailed to the wall. Correct, yeah?
Yes, sir.
Okay, now what we do, we stretch it. We extend it by x. Where is the mass to be seen now? Is displaced by a distance x. Here it is now. This is the new position of mass, small m. So of course, what you have to say, the spring is getting elongated by, tell me dear. You will say spring got elongated by x. Agreed?
Yes, sir.
Yes, sir.
What the spring is getting elongated by? It is getting elongated by x. Agreement?
Yes,
Yes,
sir.
sir.
Okay, and if the spring is getting elongated by x, then let me be an ask on. In which direction do you feel a spring will apply force on mass m?
The opposite
In
direction
which
of this.
direction spring will try to pull mass m?
Sir, will try to compress.
Yes, it is trying to pull it and pull it so as to get back to its original shape, correct?
Yes, sir.
Yes, sir.
Can we get to know the nature of spring? The nature of spring will always be to get back, to reclaim its original shape and size. Find yeah.
Yes, sir.
Yes, sir.
Okay, so that is what I'll try to do. And in that pursuit, you are also to say, not only it is trying to pull small m, but is also trying to pull the wall. Correct? Yeah.
Oh, yeah, yes,
Yes,
sir.
sir.
Because the pursuit, it is not known to which it will be able to move, but will always be on with its endeavor. And the endeavor will be to get back, to reclaim its original shape and size. So it is not only, excuse me, It is not only pulling small m, but is also pulling the wall. Correct, yeah?
Yes, sir.
But for us is of import what it is applying on a small m. So as of now, I'm discounting what it is on the wall. Correct?
Yes, sir.
Okay, so on a small m it applies a force which I am now to show and mark it as FSP. This is the force and this is the direction that it is applying on small m. In this direction and of what quantum that you know. Quantum will be as per what you find in books or packages k into x. Correct, dear?
Yes, sir.
And K for a spring, as you know, as per what is implied, I'll not say you know, but what implied over here, K is a constant, right? Yeah.
Yes, sir.
Yes,
And it is called stiffness of spring, correct? Yeah.
Yes, sir.
yes,
So
sir.
for a given spring, K must be constant, right? Yeah.
Yes, sir.
Yes,
Okay,
sir.
so K is constant for a given spring. And if I have taken a spring, it goes without saying that K for this spring is a constant, right there?
Yes, sir.
Yes,
And
sir.
as FSP is directly proportional to X, which spring we are in dealing, which spring are we studying for, linear or non-linear?
Linear
The
spring.
linear.
Are studying for linear. It goes in say that Fs can also be gotten as kx squared plus kx, so on and so forth, right? Yeah.
Yes, sir.
Yes, sir.
You can get also k changing with x. You can also get k changing with x, even for one spring. Are you getting it?
Yes,
Are you
sir.
getting
Sir.
it? Even for one spring, if you have not taken linear spring, then if one part of the given spring is thicker on mold in comparison to the other part, then K will vary internally as well. Got it, yeah?
Yes,
Yes, sir.
sir.
So we are keeping ourselves from all such variations. Am I clear?
Yes, sir.
So we are studying for the easiest one, the easiest to comprehend. Are you getting it, class?
Yes,
So in
Yes,
sir.
a
sir.
way, this is an ideal case that we are studying for. It will never be practically met because you have to adulterate it to bring it anywhere close to practical springs. Got it there?
Yes, sir.
Yes, sir.
And not only that, unless stated otherwise, we don't associate mass with spring. That is another contention with being a match with the practical ones, correct?
Yes, sir.
Yes, sir.
So those are there, of course, to be taken into account later. First, we need to get into the ideal understanding, ideal spring understanding, and this is akin to an ideal case where spring force is directly proportional to deformation, right? Yeah.
Yes, sir.
And
Yes,
when I
sir.
say spring force, I mean magnitude of it.
Mm.
Yeah.
Yes, sir.
Yes,
When I say spring force, I mean magnitude of it. Direction is decided based on experimentation that you are in. Direction is decided based on experimentation that we are in, right? Yeah.
Yes, sir.
yes,
Example in this case, spring force is in which direction you know. Now let me further. If a spring force is in this direction and you move this block slowly to the right, you start applying force here itself, and your intention was to move it slowly to right. Slowly to right. The moment I say that I am to move this block slowly to right, what I am making you understand on this applied force is this applied force cannot be constant. This applied force cannot be constant. Tell me why. Applied force cannot be constant. Tell me why did I say so? Why did I say that applied force cannot be constant? If the purpose is to make the block move slowly to right, if the purpose is to make the block move slowly to right, and coming from yesterday's class,
The
I
kinetic
told you
energy
that
is zero.
the particle is at rest.
Yeah.
Then, in order to move it and move it slowly, if the particle initially
Yes,
is
sir.
at rest, and in order to move it and move it slowly, field force should always be equal and opposite to applied force or vice versa, correct?
Yes, sir.
Yes, sir.
So this block was initially at rest, correct, dear?
Yes, sir.
Yes, sir.
And you want to move it, but move it slowly, correct, dear?
Yes, sir.
Yes,
If
sir.
you want to move it slowly, will you not always have to keep FA equal and opposite to FSP?
Yes, sir.
Yes,
Yes,
sir.
FSP in turn depends on X, correct?
Yeah.
Yes, sir.
So FSP certainly is not constant, correct?
Yeah.
Yes,
yes,
sir.
And as FSP is not constant, same goes with FA.
Yes,
yes,
sir.
FA should also not be constant. Why? Because you intend to move the block, but move it with literally zero speed, correct?
Yes,
Yes,
sir.
sir.
yes, sir.
So are you able to preempt? Are you getting some inkling on what I'm trying to from here get a guesstimation on? Are you trying to get some inkling on what basically I'm trying to gauge on? I'm trying to gauge on what will be work done by a force which can be taken, mind you, which can be taken akin to field force. I am trying to gauge here work done by a force which can be operational word can, which can be taken akin to field force. And which force I'm hinting on? I'm hinting on spring force. I'm hinting on spring force, and I am coming from yesterday's class understanding when we were calculating for potential energy of a system, right here.
Yes, sir.
Yes, sir.
When we were calculating for potential energy of a system, I told you that team import on care should be laid so as to move the body very slowly, correct?
Yeah. Yes,
Yes,
sir.
Yes,
sir.
Same I'm to air here. Exactly in toto the same I'm airing here. And what it is, certainly I'm moving block, but I'm moving it literally with zero speed, right?
Yes, sir.
Yes,
yes,
sir.
sir.
And my aim is to calculate negative of work done by spring force. My aim is to calculate negative of work done by which force I said there?
Spring force.
Spring force.
By spring force. And why did I say that the spring force can be taken as field force? Is because in few seconds from now, I will call this negative work done by spring force as potential energy. I will call this as potential energy. And the moment I'll call potential energy, you will pounce at me asking for that yesterday you defined potential energy as negative of work done by field force, right?
Yes,
Yes,
sir.
sir.
So where is field here? There is no field here other than gravitational field force, and gravitational field force is acting in the direction which is not relevant to us, correct?
Yes, sir.
Yes.
Because it will act perpendicular, right? Yeah.
Yeah.
Yes,
Yes, sir.
sir.
Of course, it is not to do any work on my system. Then why are you reading as potential energy? So I pre-barricaded myself. I pre-barricaded from your barrage of questions by straight nipping all your doubts in bud, admitting that we are assuming spring force as, tell me class,
Field force.
we are
Field force.
assuming spring force as field force. Is it clear?
Yes,
Yes,
sir.
sir.
And the moment I say spring force is assumed to be field force, I think I qualify to call negative of work done by spring force is nothing but a read on potential energy.
Yes, sir.
Yes, sir.
Okay, still you may have doubt, but sir, you also did make a statement long ago, and that was potential we do call, but only for those fields which are conservative in nature.
Yeah. Yes, sir.
Because non-conservative field, we don't know how it is changing. Therefore, we will never be able to find work done or negative of work done by non-conservative fields. Correct, dear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Therefore, we are, if at all we are to define potential, we define it only against conservative field forces, right?
Yes,
Yes,
sir.
sir.
Though we will make one departure later in 12th standard, which will be able to relate to it when we study about induced electric field. Induced electric field, though it is non-conservative, yet we associate potential with it. Why? Because we know in watts and all, how does induced electric field change. Therefore, we can find negative of work done by it. But in more cases than one, if the field is non-conservative, then we are unaware of how abruptly or how at all it is changing. Therefore, we cannot find work done by a force of which we don't have any idea in what function or functionality it is changing, right? Yeah.
Yes, sir.
In order to know what be work done, first you get to know what force you are finding the work done against. Correct? Yeah.
Yes,
Yes,
sir.
sir.
If that force is to exhibit properties akin to Mamata Banerjee, then how will you be able to find? Tell me, dear. By that I mean no offense. She's impulsive. We know that. Correct, dear?
Yes, sir.
Yes,
If the force
Yes,
is
sir.
impulsive here and there changing abruptly without any rationale, then how will be able to find what is work done by that force, isn't it? Will you be
yes,
able to
sir.
Yes,
find?
sir.
No, sir.
Not at all.
So that's the reason when we define potential, we define it only against forces which are conservative in nature, whatever force it may be. It can be a force which is different from field force as well. For example, the force at hand, right? Yeah.
Yes, sir.
Yes,
What is
sir.
this force? Of course, this is not field force, but we are treating it as field force. Why? Because in time to come, I'll prove that this is a conservative force.
Yeah, it's conservative.
Time to come, I'll prove that this is an example of force being variable yet conservative in nature. Mind you, I have already told you that generally forces which are constant are conservative in nature, and I have made an exception to that statement by making you aware of a constant force friction which is constant though it is
Not
non-conservative in nature, right? Yeah.
Yes, sir.
Yes, sir.
Today I get you a counterintuitive argument, which is there is a force which we can see varies with x, correct?
Yes,
yes,
sir.
Yes, sir.
So this force is variable force. Yet is, which I'll prove in time to come, yet is conservative in nature, right?
Yes,
yes,
sir.
Yes, sir.
And if you lay credence to what I have said, then I am within my rights to mark negative of work done by this force as potential energy. Read, agreed?
Yes,
Yes,
sir.
yes, sir.
Right, dear? Right, all of you?
Yes,
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 sir.
sir.
So write it down in words now. Negative of work done. Negative of work done by spring force. By spring force is defined as elastic potential energy. Negative of work done by spring force is defined as elastic potential energy. Clear, dear?
Yes,
yes,
sir.
sir.
Yes.
Very good. If that's the case, then let us, for this linear spring at hand, find what will be work done by spring force. Mind you, I didn't say negative. I said what will be work done by spring force. Clear?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay. This is x is equal to 0 and this is x is equal to x. Find here.
Yes, sir.
X is
Yes,
equal
sir.
to 0 and x is equal to x. Let us try to find what force acts on the block. You will say, I am to calculate dW. And for I am to calculate dW, which I'll be attributing to spring force. Correct, dear?
Yes,
Yes,
sir.
sir.
We can find work done by FA as well. Though over here, what I am first to calculate is work done by spring force. So work done by spring force is FSP dot dr, agreed?
Yes,
Yes,
sir.
sir.
FSP dot dr, that is going to be the work done equation, and FSP dot dr will be what to us when I am to extend it. What will it
Minus
read?
dx.
Mod of FSP, mod of dr into cos of the angle between them, right? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
So let us write it down. Mod of FSP, mod of dr into cos of the angle between FSP and dr, correct?
Yes, sir.
Yes, sir.
Okay. Now I write for mod of FSP. Now we write for mod of FSP, and we know that magnitude of FSP is what is meant by mod of FSP, and it is
Okay.
equal to kx, correct?
Yes, sir.
Yes, sir.
Okay, good enough. We see dr with sign. Dr now all of you are aware of. If it is only in one direction, then dr mod can be written as dx mod, right?
Yes, sir.
Yes, sir.
Yes, sir.
X can be positive or negative, which is subject to what you are doing to X, whether you are increasing or decreasing it, right? Yeah.
Yes,
Sir.
sir.
Yes, sir.
As we move from here to here, from X is equal to 0 to X is equal to X, what in this case we are doing to X is X to see an increment or decrement. Tell me, dear.
Increment.
Yeah.
Increment.
Making dx positive, correct?
Yes, sir.
Yes.
sir.
dx positive, so we can write dx as dx. Agreed, yeah?
Yes, sir.
Yes.
Yes, sir.
dx as dx, bereft of mod, as it is positive, right? Yeah.
Yes, sir.
Yes, sir.
Okay, then we come to what angle dx shares with FSP. Tell me, dear.
Sir, 180.
180. So cos of
Oh.
180 minus of 1. Correct, yeah?
Yes,
Correct,
sir.
all of
Yes,
you?
sir.
Yes.
Yes,
Yes,
sir.
sir.
All of
Yes, sir.
you?
Yes,
Okay.
sir.
This is the small amount of work which we have. Okay, good enough. Total work will then be, as you know, integration. So integration of this factor, kx dx with a minus term, minus out here. From where to where? Let us say from x is equal to 0 to x is equal to x1, correct? Or x
Yes, sir.
prime, right here.
Yes, sir.
Yes, sir.
Yes,
What we get to see from here is minus of half k x prime square. Agree?
Yes, sir.
Okay,
yes,
this minus
sir.
and minus of half
Yes,
k x prime square, and it is very logical as well. Tell me how it is logical, which is what I'll position my next question on. From where or which is what is ambiguous in books. So please be careful on this statement which I'm into making next. This is negative, and negative is logical. Why is negative logical? Because spring force is acting opposite to the direction of displacement, correct?
Yes, sir.
Yes, sir.
As
yes,
spring
sir.
force is acting opposite to the direction of displacement, work done by spring forces ought to be negative, right?
Yes, sir.
Yes, sir.
Yes, sir.
That is what we got. Work done by spring force will be negative, correct, yeah?
Yes,
Sir.
sir.
Yes,
Understood
sir.
negative now, all of you?
Yes,
Yes,
sir.
Yes, sir.
Fine. And what will be potential energy, elastic potential energy of system? In this case, what will be elastic potential energy? U.
half kx
What will
square.
that equal to?
Half kx square.
Yes, half k x prime square, correct?
Yes, sir.
Why?
Yes,
Because elastic potential energy you have defined and written as well, dear, a few seconds back, is negative of work done by spring force, correct? Yeah.
Yes, sir.
yes, sir.
Work done by spring force comes with a negative sign, negative and negative, minus and minus are to make a positive, therefore elastic potential energy is equal to half kx prime square. Is this clear?
Yes,
Is this
sir.
Yes,
extended
sir.
part clear to all of you? When you have extended
Yes,
the
sir.
spring by prime, clear or not?
Yes,
Yes,
sir.
sir.
Now let us go into the other mode. We are compressing it, right down. Let us compress let us compress the given spring. Let us compress the given spring by the same measurement. By the same measurement and find work done and find work done by the spring force and find work done by the spring force. FA this side and FSP will be in the opposite direction. Agreed, yeah?
So, won't it be
Yes,
the
sir.
same?
Yeah? Let us see. Let us see. So FSP will be in this direction, right? Yeah, right, Fresh?
Yes, sir. It should be the same. Yes.
Okay. Now what I'm into, I'm trying to compress it. So compress by what amount? I'll compress it by an amount X. So this is the position now. And from here to here, you have the compression of X. Okay, no issue. We are to find work done by spring force. We start with basic equation, and that being dw is equal to fsp dot dr, correct? Small
Yes, sir.
amount of water, which we know will be expressed as fsp the mod, dr the mod, and cos of the angle between fsp and dr. FSP we write magnitude as kx, correct?
Yes, sir.
Yes, sir.
And dr, what will be dr? Dr we know is nothing but mod of dx, mod of dr, and mod of dx. You know the relation between them, correct? Yeah.
Sir.
Yes,
Now tell
sir.
me what are you doing to x? You started from x is equal to 0, correct? This one, let us say x is equal to 0. And now it is at x is equal to some negative value, correct? Yeah.
Sir.
Yes, sir.
Yes, sir.
Into x, are you increasing x or decreasing x?
Sir, increasing x.
X positive is in this direction. And you move from x is equal to 0 to x is equal to minus 2.
So
You
you're
move from
increasing x by the magnitude.
0 to x is equal to minus 2. You have decreased or increased x.
Sir,
So you have increased x by the magnitude.
No, not that being asked. I'm asking what I'm doing to the length. Am I to take x as positive or negative? That you are to decide based on the natural length, correct? Yeah.
Sir, you have to take it as
yes,
positive.
sir. Sir,
What is the length now?
negative.
Is it greater than L naught or less than L naught?
Sir, negative.
It is greater than L naught or less than L naught?
Less than L naught.
Sir, less
So
than.
x over here, x must be negative, correct? Yeah.
Yes, sir. Yes,
And
sir.
otherwise as well, if I have taken my positive x-axis in this direction, and I am at initially at 1, x is equal to 1. Now I go to x is equal to minus 1. Then what I have done to x? I have decreased it, correct? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
So I move from x is equal to 1 to x is equal to minus 1. And that is to say that I am decreasing x. Same goes over here. What you have done to x. Exactly the same explanation holds good here. And what is that to say? What are we doing to x? Tell me what are we doing to x? What I have done to x now you know, right Trish? What
Yes,
I
sir.
have done to x now you know. We have decreased x, correct?
Yes, sir. Decrease
Yes,
x.
sir.
We have decreased x, then mod of dr, in order to make it positive, I'll have to preface it with minus sign, right?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
be clear, very clear. I'll say it should be crystal clear to you instead of gauging and getting any nuance and trying to match with what you find in books or packages. Please be in crystal clear mode. Else you will always be into crystal glazing mode. That should not be the case. Don't be into crystal glazing mode, be in crystal clear mode, and be very careful of the terms that I'm using over here, kx and dx. And then I'm to ask on the angle between fsp and dx. Firstly, let me ask you, is it crystal clear or you will be into crystal gazing? Crystal gazing means you are not clear. Crystal
It's
gazing, you know,
clear.
crystal gazing act. We are trying to see future. Okay, so that should not be the case. Is that clear to you? That why did I
Yes,
write
sir.
minus of dx? This is important. Why did I write minus of dx?
Yes,
Clear
sir.
to all of you?
Yeah. Yes,
Yes, sir.
sir. Yes, sir.
Okay.
Yes, sir.
And then the angle. If that is clear, then let me ask you about the angle. FSP
Zero.
to the right and dx to the dr to the left, correct?
Yes, sir.
FSP is to the right, as you can see from here, and dx or dr is to the left. Agreed?
Yes,
And
sir.
the angle which we get will get you the value of cos theta minus 1. Agreed?
Yes, sir.
Yes, sir.
Okay, let us now find W when we are moving from x is equal to 0 to x is equal to x prime. And write it down over here. Minus minus plus. So half k x prime square. Right there.
Yes, sir.
Yes, sir.
Yes, sir.
Now you see a departure. You see a departure. Please see for yourself. What do you see? You see that even if you say -1, see, don't get confused over here. X prime, even if it is negative, you mark it this way. Minus of x prime, no issue. Is it okay? It'll be this
Yes.
only, right? Why? Because when you integrate, you will be getting x square by 2. Correct, yeah?
Yes,
Yes.
sir.
So you'll
Yes.
end up getting this only. There will be no minus sign. Correct, yeah? Agreed or not?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Now I am getting work done by spring as positive. This should raise eyebrows. Work done by spring being positive, this should have raised a question. I await a question from your end. Tell me what question you are or you should ask. Because I cannot stomach it. I don't know what objection I do have with this. I want that objection to be raised by you, so I don't know what objection it is. But I cannot stomach work done by spring being a positive. The reason you better know, as we deliberated few minutes back. Why I am not accepting, why I am not able to stomach work done by spring force being positive here, which is what I am getting.
Is it because elastic potential energy is negative or work done by spring force, and elastic potential
Now
energy
my
will be
question is
positive?
very simple. My question being very simple. In the previous case, I justified work done by spring will be negative, correct?
Yeah. Yes,
Yes.
sir.
Yes.
So the reason is because in a
What did
closed
I
path,
justify?
sir,
I
because spring force
justified
being
because spring force and displacement, they were in opposite direction, right? Just keep it very
Yes,
simple.
sir.
sir, is it
Keep it,
because
let us not confuse ourselves. Because simply the spring force and displacement, they were counter on direction, correct?
Yes,
Yes.
sir.
Okay. Here, the case is no
doubt?
different from previous.
So just one thing, is this the answer? Because see, spring force being conservative, work done on a closed path by spring should be zero. So
Hmm.
so if you displace it by x this side and x the other side, so if it's a closed path, so work done should be zero.
Conservative, when we say Krish, then we need to prove that it is conservative. We cannot take conservative as an axiom or postulate. Okay? When I say conservative, then I have to mathematically prove it. Correct? Yeah.
Yes, sir.
So I cannot take an axiom that it is conservative in nature and accordingly tweak minus or plus. That I cannot do. Even if I take it as an axiom, I cannot tweak it based on my statement. I'll have to mathematically prove it. One is a statement which you experimentally found, right, Krish?
Yes, sir.
You found experimentally okay. But that experiment, nobody is to lay credence to. Nobody will pay heed to. They will simply reject it unless and until you have mathematical substantiation, correct?
So if you use the formula you told that day, uh, that
And
fx,
yeah, that curl formula.
it's a
Curl
curl
formula
form.
that we use, and then from there, if you get zero, then we
I
have
got.
proved mathematically that it is conservative false. Correct. It
Yes,
can
sir.
be. But then my question over here, very simple summation being, Krish, if it is so, then I should get it by this mathematics as well, correct?
Yes, sir.
Why will I be beholden by only one mathematical process? If it is so, then I should get the same by following mathematics. I cannot change mathematics based on a statement, correct?
Yes,
Because to prove statement, I require mathematics support. So I
yes, sir.
should get the same by mathematics. And any mathematics which is correct, which you are into following in toto, should lead to the same result. And this is exactly where lies positions where books and packages do go wrong. When you write FSP mod, when you write FSP mod, we write it as KX. FSP mod is not equal to KX. Why is not equal to KX? Because X can be positive or negative.
Oh yeah. Yes, sir.
X can be positive or negative. That depends on which side of 0 you are. If you are to right of 0, x is positive. If you are to left of 0, then x will be negative. So FSP is never equal to Kx. Yes, what you can say is equal to FSP x. Sometimes you will always also find FSP is equal to, they will write FSP is equal to minus of Kx. This is equally wrong. They will also write, you will find at times, FSP is equal to minus of Kx. This is equally wrong. FSP, if you take minus of Kx, you will get again a result which you will not be in any position to accept. Then what is minus of Kx? FSP x component is minus of Kx. X component of spring force is equal to minus of Kx. And then comes, how can you justify with whatever you have said over here? How can you justify this being changed to a minus? And so you can easily justify this being changed to a minus. How? What you do? You now say FSP mod is equal to mod of Kx. FSP mod is equal to mod of Kx. Is it okay?
Yes, sir.
Yes, sir.
What is FSP mod? Hitherto, what are you to read FSP mod to be? Mod of Kx. Now, the moment you read mod of Kx, and then you remove modular sign, see for yourself, I apply mod now. Is it okay?
Yes, sir.
And
Yes,
then I want to remove modular sign. But it is known to me that inside of the bracketed or mod symbol, term Kx is negative. Agreed?
Yes, sir.
yes,
Which case it will be negative, compressed or extended?
In case of compress.
Compressed. Because extended will be to the right of 0, there it will be written as Kx only. Here I'll have to preface it by a minus sign. Correct here if I remove mod. If I nurse an ambition to remove mod, I'll have to preface it with a minus sign. Agreed or not?
Yes, sir.
Yes, sir.
yes, sir.
And the moment you preface it with a minus sign, minus will be retained and this will appear with minus, right?
Yes, sir.
Yes,
Sir.
sir.
So our concern got addressed, correct?
Yes, sir.
Yes, sir.
In that pursuit, we got to know that what exactly is mod of FSP. Mod of FSP is never equal to Kx. Mod to the left of equality means it should be equated only with mod to the right of equality, which is what to get us this relation. Once you know this, you are sorted. Take x in whichever direction you want. You will always get a correct answer to all your findings. You can take x in any direction, left, right, whatever you want. You'll get to see that this will lead to the correct answer. Find ya?
Yeah.
Yes,
Yes,
sir.
sir.
Okay, so this is the only which I wanted to highlight. This being highlighted, rest there is nothing much in spring falls. Why? Because we know that spring falls is only studied in work power energy as a component or as a repository of energy. And what energy? Elastic energy. What we read it as is elastic potential energy. A very pertinent question can be in any point in time asked, which is you associated spring with potential, what about kinetic? You associated spring with potential, what about kinetic? And that for the time being, we are dismissive of reason we have taken spring with zero mass, correct? Yeah.
Yeah, yes, sir.
Yes, sir.
So we are dismissive of spring being associated with kinetic energy. Though in questions, I am to get you springs with mass and then will ask what kinetic and what potential can be associated with them when they are deformed by X. Find ya?
Yes.
I'm letting you know what is incoming. Please be always on with thought process. Never cloak yourself with what you are to limit yourself to as far as preparation of IIT being asked. The reason they can get you a comprehension and then you will land yourself in soup. Suppose in comprehension they got you that there is a spring with mass and then understand theory related to it. I can say for sure that you will be not able to decode from theory and understanding with a time dangler. So that part will be completely off your realm. You will not be able to score off that comprehension. On contrary, if you are known to what they can extend to, for example, 3 years ago, when Coruscant's first question was asked, we know that that was not in syllabus, so it wasn't taught. And the student got caught off guard because all of a sudden they got first, which was not known to them, and a comprehension on it. But there were a few students who are taught in various coaching institute on Colossus Force, and they then stood game. So if you know that few things can be asked, which were there previously but are not there to be seen anymore, so they are to run a risk of being asked by IIT in comprehension form. So why not to get done with those? And we'll get done with those, of course, not as theory, but questions. So you won't be getting, I'll be getting you questions. So you will be updated with questions in which springs are to come with masses and you are to find what is kinetic and potential energy stored with them. Before of me taking it, please try to brood on it and then get some methodology of finding kinetic energy associated with spring. For now, it's only potential as I have taken a spring with zero mass, correct?
Yes, sir.
Yes, sir.
Okay, now what questions can be on this position? Write down. What question, various questions which you can get positioned on this spring concept. Please do write. First question. A spring of spring constant K. A spring of spring constant K is initially compressed. Is initially compressed by x is equal to x1 is initially compressed by x is equal to x1. Find kinetic energy of a block. Find kinetic energy of a block when find kinetic energy of a block when the block moves from when the block moves from position x1 to x2. When the block moves from position x1 to x2. Is it fine with all of you? K is the spring constant. K is the spring constant. This is the block of mass m. You have to find speed. What did I ask? Kinetic energy or speed? What was it?
The kinetic energy.
Kinetic energy of block when it moves from x is equal to x1. Since it is compressed, so I have used minus x1. So x is equal to minus x1, x is equal to minus x2. What will be, which theorem will be into uses? Work energy theorem, isn't it? Work done by all the forces is equal to change in kinetic energy, right? Yeah.
Yes, sir.
Yes, sir.
Let me put that equation. Normal is acting and acting upwards. Mg is acting and acting downwards. So normal and Mg don't qualify being any work measurement, which is the only force that can do work here.
Spring force.
Which is the force, as there is no friction. So the only force which you can associate or attribute work to will be spring force. Agreed, yeah?
Yes,
Yes,
sir.
sir.
So work done by spring force, should be equal to change in kinetic energy, right?
Yes, sir.
Yes, sir.
Yes, sir.
Will do what work is known to you. Spring force will do what work is known to you. Because work done by spring force, just now you have calculated. Let me remind you on it. FSP dr into cos of the angle theta, and then you have to integrate from where to where? Minus
Minus
of
x.
x1 to minus of x2, correct?
Yes, sir.
Yes, sir.
Okay, now tell me, FSP, what shall I use? Minus plus. This was 0. Minus of kx or plus of kx?
Uh,
Minus.
minus.
Minus. So minus of kx, find here, done. dr. dr, I am to use plus of dx or minus of dx? Displacement. Displacement means it was initially compressed and then you let loose. If
Then
you
it will be
let
plus of
loose,
A. Plus
yeah,
of A.
x will increase, right? Suppose it is moving
Yes,
from
sir.
minus
Yes, sir.
of 5 to minus of 2. Are you getting it?
Yes,
Yes,
If
sir.
sir.
you go from minus of 5 to minus of 2, then actually you are increasing x, correct here?
Yes, sir.
Therefore, this can be written as dx. And then we go for FSP and dr. FSP will be in which direction known to you? FSP will be this way, agreed, dr.
Yes,
FSP
sir.
and dr is also in the same direction, right, dr?
Yes,
Yes,
sir.
sir.
The angle between FSP and dr cos 0, 1, right?
Yes, sir.
Yes,
Then we
sir.
integrate from minus of x1 to minus of x2. What do we get from here? You can tell me. Minus of x1, minus of x2. So minus sign I retain kx square by 2, correct here?
Yes, sir.
Yes, sir.
Okay, and from where to where? From minus of x1 to minus of x2, right there?
Yes, sir.
Yes, sir.
Okay, good enough. What will this get you? Half k bracket open x1 square minus x2 square. Please do check. I have taken the minus sign inside. I have flipped the limits and taken the minus sign inside. Find ya?
So
Take it,
one,
take it.
Yes, sir.
Is it okay with all of you?
Yes, sir.
And is it Krish okay? Adesh okay?
1 second, sir. I'm just thinking.
Okay.
So how? No, I got it. No.
Yeah. Yes, sir.
Yes, sir, got it.
So positive, negative doesn't
Yes, sir,
matter,
yes,
right?
sir.
And then this is minus. You can flip it now from x2 to x1 to bring that minus inside.
Yes, sir.
Yes,
So
sir.
that is what I have done. Got it,
Understood.
Adesh?
Yes, sir.
And we should be getting a positive quantity, which is what we have got finally, correct?
Yes, sir.
x2, x1 is
Yes,
greater
sir.
than, magnitude wise, x1 square will be greater than x2 square, correct? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
So we should get a positive quantity and positive what we get, correct? Yeah. Spring was to do a positive work and that is what we are getting, correct?
Yes,
Yes, sir.
This we know will be equated to change in kinetic energy, half mv square minus 0, right?
Yes, sir.
Yes, sir.
On block, final kinetic energy is with v to be associated, so half mv square and minus 0. That is what we began with. Work done is equal to change in kinetic energy, right?
Yes, sir.
We've got work done and we'll equate it to change in kinetic energy and that will get us V. Correct? Yeah, all of you.
Yes,
Yes,
sir.
sir.
How much is V from here? K x1 square minus x2 square by m whole under the root. Correct?
Mm, yes, sir. Yeah.
Right?
Yes, sir. Yes, sir.
Yes, sir.
Okay, now question on your understanding. That means when the spring is in compressed state, when the spring is initially is in compressed state, and then someone says that spring is moving from or block is moving from x1 to x2. Someone says that block is moving from x1 to x2. Is it okay? And the person says that it can be positive, it can be negative. He has not made you aware of what is x1 and what is x2. Am I clear?
Yes, sir.
Yes,
It
sir.
can be anything.
Yes,
It
sir.
can be fine. The person just says, fine, I'm not even getting you that statement or that mode of thinking. I am just getting you one mode, and that being x1, x2 given to you. Forget about being positive, negative, whatever it may. X1, x2 being given. If you want to take positive, take both positive, no issue. So x1 and x2 both are positive. And then is being asked, what will be work done by spring force? It can be only positive, it can be only negative, it can be positive or negative. A spring which was initially compressed moves the block. Is my question clear? A spring which was initially compressed, now it let loose to fend for itself. And then it moves the block attached to it from where to where? From x1 to x2. And for simplicity, both are positive over here. X is equal to x1 to x is equal to x2. X is equal to x2. And then being asked, what can you say about work done by spring force? Will be positive, will be negative, can be positive or negative. Tell you.
Both are positive.
Okay.
No, sir. I'm asking, are both positive? X1 and X2.
They're positive, they're positive.
That's not my answer.
Both are positive. Both are
Yes, sir.
positive. What shall it be?
Uh,
Can it be only positive? Can be only negative? Or negative, positive, both do qualify a mention.
Sir, and is X2 greater than X1?
X2 is greater than X1.
then is it negative?
Okay. X2 is greater than X1, given to you. Work done by spring force, what will it be?
Sir, it should be positive, I guess.
So positive.
Positive.
Okay. Okay. Now this is a very important aspect. That's the reason I did dwell for this long, as there are questions which you have to solve based on this concept. Unless and until is known to you what is the natural length of spring, you cannot say it will be positive or negative. Unless and until is known to you what is natural length of spring, you cannot be in any state to cement your position on work will be negative or positive. Now, why did I say so? Let us say natural length of spring is this one. Is it okay? Let us say. You getting it?
Yes, sir.
If this is the natural length, then through and through, when the particle of body was moving from x1 to x2, the spring was in compressed state.
Yes, sir.
And if it was in compressed state, then work done by spring will be positive.
Yes, sir.
Because spring falls in this direction and displacement also in this direction. So in that case, you would have got work done by spring as positive.
Positive.
Whereas if this is the natural length, are you getting it?
Yes,
Yes,
sir.
If this is natural length, and then you move it to the right of the natural length, that means when you're extending it, then what you will be getting work done by spring as negative.
okay.
Okay?
Yes,
Why? Because trying to pull it and spring is and the block is moving to the right. Correct? Yeah.
Yes,
yes,
sir.
sir.
So then work done by spring force will be negative. Now you may argue that I did make a statement on spring being compressed. I'll say yes, I did. So spring being compressed, but I refrain from saying anything on x1, x2, right dear?
Yes, sir.
Did I tell you that x1 is, or x2, not x1? Did I tell you that x2 is less than natural length or more than natural length?
No, no, sir.
So natural length can fall to the right or it can fall midway. Anywhere.
Yes,
Yes,
sir.
This can be natural length. Let me take another chalk piece color. This can be natural length. Can you say this can be natural length? Agreement?
Yes, sir.
yes, sir.
So if this is the natural length and I mark it as x is equal to x1, x3, then tell me now is on your understanding. From x1 to x3, what will be work done by spring force, positive or negative? x1 to x3, work done by spring force will be positive or negative. Let me tell you, from x1 to x3, spring was in compressed mode. Yes, Krish, you're saying something. As x1 to x3,
Yes, sir.
what will be work done, positive or negative?
Sir, x1 to x3 positive, sir.
Positive.
Yes,
Positive.
and x3 to x2,
X3 to
Negative.
Negative.
got it then. Now
Yes,
you
sir.
can very well summarize it that when the spring is in compressed state, or rather I'm asking, let me ask you a question. The spring is in compressed state. The spring is in compressed state. Okay? Work done by spring. Option A must be positive, must be negative, maybe positive, maybe negative. Now, every aspect is to be checked carefully, very carefully, meticulous, very meticulous observation is required here. Please don't make any perception. Please don't be of a dog mindset. Why I am telling you this is owing to the fact that if I ask you this question, that spring is in compressed state, what we
sir,
work done by spring force,
so
then what are you
according
to tell me the answer to this? Tell me.
so for me it's option 3 and 4, maybe positive and negative.
Exactly,
Yes,
very
sir.
because compressed state if it is in and trying to extend, are you getting it?
Yes, sir.
If it is in compressed state and trying it is to extend, then work done by spring force will be positive, correct?
Positive.
Yes, sir.
Yes,
Yes,
sir.
sir.
And it is trying to. Then work done by it will be positive.
Positive.
But being in compressed state, suppose it is in compressed state and the body was moving to the left. Happen? Of course, very much possible, right here. Yes or no?
Yes,
Simple
sir.
asking.
Yes, sir.
It is compressed, yet the block is moving to the left. Correct here?
Yes, sir.
Yes,
In
sir.
that case, what will be work done by spring force?
It'll be negative.
Will be negative. Is it okay? So this will be clear, all of you, all three of you. Questions are into
Yes,
coming
sir.
on this pattern. Clear, all of you?
Yes,
So
sir.
never make any statement. We can never be sure of unless and until we are privy to the exact scenario. Got it?
Yes, sir.
Okay, good enough. Now let me take a few questions of higher order. Write down. Given two blocks, given two blocks, given two blocks M1, M2, are placed as shown in the figure. Given two blocks M1, M2 are placed as shown in the figure. Find the minimum force F. Find the minimum force F, which when withdrawn, find the minimum force F, which when withdrawn will make the lower block bounce. Find minimum force F, which when withdrawn will make the lower block bounce. So this is a question at hand. There are two blocks. There is a spring constant K. You have applied force on the upper block. So you are compressing the spring, correct, yeah?
Yes, sir.
The spring is in compressed state. That compressed state you can also get by a thread. You can also place a thread which is stout. So the spring is compressed by some amount. And then what you do, you either cut thread if you have taken thread, or if you have applied force, you withdraw that force. And when you withdraw force, your purpose of force withdrawal is to see M2 bounce. By bounce, I mean it will lose contact with floor. So what should be minimum value of F for M2 to lose contact with floor? Am I clear?
Yes, sir.
That
Yes,
is what
sir.
is being asked. That is what is being asked. How will you go about it? We'll go by safely, we should go by work energy theorem always, isn't it? If we are not sure conservation of mechanical energy will hold or not, then better always is to go by work energy theorem that holds. That holds for any case, correct, yeah?
Yes, sir.
Yes, sir.
So work energy theorem. Let us take FBD for the bodies. And let me ask you one question, which is, when you feel M2 will lose contact with ground, when the spring is in compressed state or elongated state? When, according to your comprehension, M2 can leave ground, when spring is in compressed state or it is in elongated state?
Sir,
What is,
elongate.
Elongated.
of course, elongated, because till the time it is compressed, it will press M1 up and M2 down. Correct, dear?
Yes, sir.
Yes,
Yes, sir.
sir.
It will try to get to its original shape. Correct, dear? So what will it do? It will push M1 up and M2 down.
Um,
To compress will certainly not address our case. The spring should be elongated, and when it is elongated, It will try to pull M1 down and M2 up, correct?
Yes, sir.
It is elongated again to get back to its length, original length. It will pull M1 down and M2 up.
Up.
So M2, there is a force in upward direction, and that is equal to, let us say, Kx. Here, what X stands for? Length beyond natural. Can we say that?
Yes, sir.
Yes.
Okay. X stands for, if this is the natural position, if this got to be the natural position, then it has got beyond it. Correct? You can say it is somewhere over here. Correct?
Yes.
Yes, sir.
Yes, sir.
Length is how much to us? From here to here, this length is how much to us? Is X to us. Correct? Check
Yes,
it out.
sir.
Yes, sir.
Okay. So now you can say for block to get lifted, normal must be 0. Agree?
Yes,
Yes, sir.
For this
Yes,
block to
sir.
get lifted, normal must be 0. Agreed or not?
Yes, sir.
Yes, sir.
And that will happen when Kx, that you will be able to achieve when Kx is equal to mg, right?
Yes, sir.
Yes, sir.
After 0 is indicative of Kx being equal to mg, which gets you x. Which gets you x? m2g by k, correct?
Yes, sir.
Yes,
At
sir.
this value of x, all of you please, careful. At this value of x, at this extension of spring, can you say that?
Yes, sir.
Yes, sir.
At this extension of spring, M2 will leave ground, or M2 will be about to lose contact. Can we say that?
Yes, sir.
Yes, sir.
When M2 is about to lose contact or has left ground, then M1 can be in two states. By that, what I mean, M1 can be either at rest or M1 can be in motion, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
M1 I don't know anything about. M1 can be either at rest or M1 can be in motion. Yes, I know about M2. M2 is at rest, right?
Yes, sir.
Yes, sir.
Okay. Now about M1. We don't know what state it is in. This is M1 too. This has left ground already. We go back to work energy theorem. Is it okay, Krish? Krish, what are you saying something?
No, sir.
Okay. We go back to M1. Now we shift our attention to M1. And on M1, I calculate next by uses of work energy theorem. What are the possibilities? So on M1, possibility number 1, that M1 is moving with some speed. Is it okay? That
Sure.
M1 is moving with some speed. Okay, no issue. Now, work done by M1G on M1. How much? Work done by M1G on M1.
So
What
it will
will you
be
say?
M1
Work
GX.
done is nothing but force multiplied, constant force multiplied with displacement. Agreed here?
Yes, sir.
Agreed.
Yes, sir.
And displacement of which body? Which body we are now? We have shifted our focus to M1, correct?
Yes, sir.
Yes,
So
sir.
what shall I do? I should multiply M1G by the distance it has moved up, correct?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
by what distance M1 did move up? Anyone? By what distance M1 did move up? And mind you will have to take from the beginning. You will have to take from beginning because M1 through and through did move upwards. Correct, yeah?
Yes, sir.
Okay. So you don't know what was it compressed by? Plus X. Check it there. Check it. Check out. Check out. Very important this.
Delta, is that delta X?
Delta X is what it was compressed. The spring was compressed initially too. So
Yes, sir.
first from compression, it will reclaim its shape, correct?
Yes, sir.
And then after of
So your videos, sir. Are you people able to see him?
No.
Sir, your video is not visible.
Ah, dear.
Yes, sir. Now it's fine.
Now you're fine.
Okay.
It's
Now,
blurry.
X went up to, sorry,
Sir, again. So you're not visible again.
That's gone. Yeah.
claim it shaped here. It went up by delta X. Can we say that?
Yes.
Yes,
Sir.
sir.
Yes.
Okay. And did it stop after reclaiming its shape? Of course not, correct?
Yes, sir.
Yes, sir.
It went beyond because it was to pull M2 up. So it went beyond. It went beyond by what quantum? X. Can we say that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So total distance moved by M1.
This is delta x plus x.
Where to all of you?
Sir.
Yes, sir.
Yes, sir.
And will the work be negative or positive? Will the work done by M1G on M1 be negative or positive?
1 second.
M1G is down here and movement of block is upward.
Yeah.
Tell me
Negative.
quickly.
Negative.
It'll be
Negative.
Sir,
So what
negative.
is the work done by M1G? And
negative.
then comes the other force acting on it, which is spring force, correct, yeah?
Yes, sir.
Okay. So what will be work done by spring force? Will it be only positive, only negative, or combination of positive and negative? Will it be only positive, only negative, or combination of positive and negative? Come on, all of you know this
It will
now.
be
Sir, a
combination
combination.
of, combination of positive and negative.
Be a combination.
When it was trying to regain its original shape, half k delta x square. What was this? This will be positive, correct? Yeah.
Yes, sir.
And then when it went beyond delta x, then it is minus of
Negative.
half k x square negative. Correct? Yeah. Check it out. Very important this.
Yes, sir.
Very important this. Is it okay?
Yes,
Yes,
sir.
sir.
Yes.
Okay, so this is work done by spring force. Previous was work done by M1G, correct?
Yes, sir.
Now this can lead to change in kinetic energy of M1 or kinetic energy can be zero. Both the possibilities we are up with, correct? Yeah.
Yes, sir.
Yes, sir.
If you say that this is to equate to zero, let's say, that means you are suggesting when M2 did leave ground, then M1 was at rest, correct?
Yes, sir.
Yes, sir.
Is it okay? Because I'll place the value of x. I don't know delta x. From here we have to get delta x. But x is known to us. What is x? M2G by K, correct? Yeah.
Yes, sir.
Yes, sir.
And if I equate it to zero, kinetic energy of M2 certainly zero. M1 we don't know. But if I'm equating it to zero, it is suggestive of kinetic energy of M1 being zero. That means when M2 did leave ground, M1 was at rest, correct?
Yes, sir.
Yes, sir.
The other can be when M2 did leave ground, then M1 was having kinetic energy which is half M1 V square. Is it okay?
Mm.
Okay.
Yes, sir.
Work done by all the forces are change kinetic energy. That's it. I'm writing both the equations over here. Is equal to 0 or is equal to half m1 v square. Find here.
Sir.
Now, I ask you, all of you, which of the two equations will get minimum value of delta x? Please read the language of question. In the language of question was categorically mentioned delta x should be minimum. Was or not?
Yes, sir.
Or minimum value of force was mentioned or not?
Yes, sir.
So minimum value of force will correspond to minimum value of delta x. Agreed or not?
Yes, sir.
Yes, sir.
Yes.
and delta x to be minimum, shall I go with this being equated to 0, or should we with this being equated to half m1 v square?
No, to 0.
Of course 0. Why? Because you press it by this value of x or thrice of or quadruple of this value of x. One thing we are sure of, that m2 will bounce. M2 will bounce when x is equal to m2g by k. It has got nothing to do with by what you are compressing it. Agreed or not?
Sir.
Yes, sir.
Yes,
If I compress it with twice, let us say, I compress it with twice of m2g by k. I have pushed it further. Find here.
Yes,
Yes,
sir.
sir.
yes,
Will m2 bounce at different value of x or same value of x?
The same value.
Of course, because m2 is to bounce based on normal becoming 0, correct? Yeah.
Yes, sir.
And normal will get you 0 for this value of x, correct?
Yeah, yes, sir.
Yes, sir.
yes,
But you pressed it by twice of this, correct?
So it
Yes,
will
sir.
be converted to kinetic
So
energy.
that differential energy, that work done by you, where will it reflect? It cannot
Kinetic energy.
reflect in M2's kinetic energy because M2 is at rest, correct?
Yes, sir.
Yes, sir.
yes,
Where will
sir.
it reflect? In
M1's
kinetic
kinetic.
energy of M1, correct? Yeah.
M1. Yes, sir.
Because spring is again compressed by same amount or elongated by same amount, correct? Yeah.
Yes, sir.
Yes, sir.
Yes,
So no spring energy. The other form, the only display for the differential is kinetic energy of M1, correct?
yes, sir.
So if I want compression to be minimum, then kinetic energy of M1 when M2 is leaving must be,
This one, minimum. 0. 0.
come on, all
0.
of you please. Kinetic energy
Minimum.
of M1 when M2 is leaving for minimum compression of spring should be
0.
0.
Zero.
So we will go with this equation. This is the equation we have to go with. X is known to you. Place the value of x and you will get the value of delta x from here. Now, delta x will come equal to, I am writing it down for you, twice of the upper block plus the lower block into g by k. You can check. Okay, you can check. It's a different. It's appearing to your quadratic equation. It is a quadratic equation, but very simple. It will not giving you much of pain. You can solve it, and you'll be getting delta x is equal to 2m1 plus m2 into g whole divided by k. Find here.
Yes, sir.
Yes, sir.
Twice of the block at top plus block at bottom. Remember it this way. Twice of the block at top plus block at bottom into g divided by k.
Yeah.
Now, sometimes this comes with a tad confusion. So let me clear that off. If you have applied force right from beginning, that means the block was brought and you started applying force. Is it okay?
Yes, sir.
Yes, sir.
Then you will get this as the answer. If you let the block settle, mind you, what did I say? If you let the block settle, that means block has itself compressed the spring already. Are you getting it? Already the
Yes, sir.
block has compressed the spring. And then you start applying force. Got it?
Yes, sir.
Yes, sir.
Then the answer will be without of 2. Okay? Then the
Yes, sir.
answer will be without of 2. Both the answers you are to lay equal credence to. It depends on the articulation of question. If the question says that right from beginning force was applied, then there will be 2. If the question says that no, it got settled and then force is applied, then there will be no 2. Why will there be no 2? Because it was already compressed by M1 into G now, right? Yeah.
Yes, sir.
Yes,
It
sir.
was already compressed by M1 into G. Therefore, instead of twice M1 into G, from this one M1 into G will be removed. So you'll be left with only one M1. Correct? Yeah.
Yes,
Yes,
sir.
sir.
Got it? Got it or
Yes,
not?
sir.
Yes,
Yes.
sir.
Yes, sir.
Okay. So Erudo has used string and then he has taken 2 into account. Okay? They have asked you that they are same masses. So what should be the minimum value of delta x? What we will get? Delta x is equal to 3 mg by k. Agreed? If the masses are same.
Yes, sir.
Yeah.
Okay, so this is what has Erudo answered to the question that, of course, is his brainchild. If is asked, you will find nowadays they will try to play with language. So be very careful of it. Though IT will refrain from it. IT will make it amply clear what they want. And if they don't want, they will not put that as option because that is not the purpose to confuse student. So, but in day-to-day, everyday kind of examination, they mean. If F is applied right from beginning, then 2 will feature. Clear?
Yes, sir.
Yes, sir.
If is F applied after of settlement, 2 won't feature. Clear?
Yes,
Yeah.
Yes, sir.
Yeah?
Yes, sir.
Yes, sir.
Okay, fine. So anyway, today's spring did take good length of time. There are many questions on spring and we cannot be dismissive of those. So let's see the next day I'll be taking vertical circular motion. Okay.
Sir,
Yes,
sir, today there's no class in the evening, no, sir.
Today I have class with the other batch in the evening, with foundation batch in the evening. If I
Not-
do, evening is free for all of you or what?
No, sir, for me there is Akash today, sir, and it's quite important today. That's why.
Okay, fine. Then in that case, I won't keep. Tomorrow, what's the scenario? If it's required tomorrow to extend, I may be extending.
Sir, I actually have the school has made an announcement that they're going to stop online classes. So in the morning, I'm free. Yes, sir. But tomorrow's the last. Sir, in the morning I'm free. That means.
Morning till what time?
So morning I'm free till I'm free, sir. Complete full morning. So
Achha,
tomorrow only 1 hour class.
morning means up to 3 or free, is it?
Yes, sir. Till up to 3, 4 I'm free, sir. Up to 4 I'm free.
Okay, fine. In that case, and is the case same with all of you? The other two?
yes,
Vedant and
yes,
Nadesh?
Yes, sir. It's just that from Thursday today is Wednesday, right? So tomorrow I have Alan. I joined Alan. So every Thursday, Saturday, and Tuesday there'll be class from 4:30.
4:30.
4:30 or
4:30.
5:30. One. Huh?
4:32?
So I think 4:30 or 5:30 till 8:30. Till 8:30.
Okay. So in any case, tomorrow I'll require just 1.5 hour time to get done with vertical circular motion. And if tomorrow I'm to initiate rotational mechanics, then I'll be initiating. Else tomorrow we'll be indulging in question solving for work and work by energy portion. Fine, dear?
Yes,
Yes,
sir.
sir.
yes, sir.
Okay. Tomorrow there can be an extension, so I'm just making you forewarn on that. Fine, dear?
Got it. Yes,
Yes,
sir.
sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.